Hi, folks. Thanks for joining us for the second webinar in this two-part manufactured homes webinar series. So today we're going to be looking at ductless heat pumps and manufactured homes. We'll get started right away just so that we can take advantage of the full 90 minutes. So I'm going to start with a quick introduction, and then I'll pass things over to Ryan Coleman and Rob Pope of Ecolighten Energy Solutions to speak on ductless heat pumps and manufactured homes. And then after Ecolighten's presentation and facilitated discussion, Juan will take the stand. He's here with FortisBC, and he's going to introduce us to FortisBC's rebate programs. So I'll just get started with the next slide there, please, Ryan. Perfect. All right, so the Community Energy Association, we acknowledge that we carry out our work on the traditional and ancestral territories of Indigenous peoples. So through our commitment to truth and reconciliation, we support First Nation, Inuit, and Métis communities in taking climate action and reaching their goals of energy sovereignty, security, and resilience. So I'd just like to begin our session today by acknowledging the Indigenous people from all of the diverse and beautiful places we're joining from. So I'm joining from what is now known as Nelson, but for thousands of years has been the traditional homeland of the Snakes Nation, the Ktunaxa Nation, and Silks people of the Okanagan Nation, and is home to the Métis and many diverse Indigenous people. So I just like to acknowledge with deep respect and gratitude that it is in thanks to their generations of stewardship that we're able to enjoy these mountains, forests, and waters in the way that we do. So as part of my commitment to truth and reconciliation, I'm educating myself about the history of colonization and the cultures that were lost. And I challenge you to learn what you can about the unceded Indigenous territories that you build, live, work, and play on. So I've started my journey. Sorry, I'm just going to unmute or mute. Perfect, thank you. So I've started my journey with a book written by Bob Joseph called 21 Things You May Not Know About the Indian Act. So wherever you are on your journey, I do suggest reading this book if you haven't, just to gain a better understanding of how after 140 years, the Indian Act continues to shape, control, and constrain the lives and opportunities of Indigenous people. Perfect. All right. So who are we? CEA, or Community Energy Association, is a registered charity and nonprofit. We're committed to accelerating bold action by local governments and Indigenous communities related to climate and energy. So CEA's staff, board of directors, and members are a community of individuals, communities, and organizations that accelerate local action on climate and energy through their collective capacity, expertise, experience, passion, and commitment to truth and reconciliation, and the United Nations Declaration on the Rights of Indigenous People, or UNDRIP. So CEA's work recognizes the transportation and the built environment as the main sources of community-based GHG emissions, and that action in these sectors can result in significant GHG emission reduction, enhanced community resilience, and energy security. So we've introduced the Kootenay Clean Energy Transition Project. Just on the next slide there, please. So perfect. So today's webinar is an initiative through the Kootenay Clean Energy Transition, and KSET's a project designed to respond to changes in energy efficiency, renewable energy, and home comfort space. So through KSET, we aim to assist Kootenay and boundary communities in preparing for a more energy efficient and healthy future by providing training and capacity building sessions like this one. So thanks to the generous support of the organizations listed at the bottom of the slide, we're able to offer this workshop for free as part of that initiative. And to see a full list of any other upcoming workshops and webinars, just make sure to visit our webpage at communityenergy.ca/built environment there. And you'll also find an opportunity to sign up for our high performance building newsletter that'll keep you in the loop with any upcoming workshops and training initiatives we're bringing to your communities. All right, and then the Home Performance Contractors Network, one more plug here. So for those of you on the call who are doing retrofits, I just wanted to introduce the Home Performance Contractors Network. If you're doing heat pump installs, window and door retrofits, or installation upgrades, and your clients are wanting to access provincial and utility rebates, this is the network for you to join. So becoming a member involves industry-specific training, and then upon completion of the training, you can receive training subsidies and costs back for the course. So if you have any questions about the Home Performance Contractors Network, you can reach out to Bailey on the slide there, or Brady, sorry, on the slide. All right, so finally, my last pitch here, CEA, we're dedicated to offering educational opportunities to all, no matter their current knowledge or experience level. So we prioritize creating a safe and welcoming environment for attendees to engage and participate. So this slide just outlines some guidelines we ask everyone to follow for the next 90 minutes. So above all, please just show respect to our speakers and fellow attendees. Feel free to ask any questions you have. We're happy to address them. So I'm about to pass things over to Rob and Ryan, but just wanted to cover a couple more housekeeping items. If you have questions as we go through the presentation, feel free to raise your hand and we'll call on you to unmute yourself. If you'd rather put your question in the chat, that's totally fine. We'll do our best to kind of address them through the presentation, or we may decide to wait until the end of the presentation, just depending on the question, but we will get to all questions in the chat. You will have noticed that we're recording the session, so we'll be hosting it on our CEA webpage there. We'll also be sending a link out to everyone who's registered, along with a copy of the presentation slides. All right, so it's with great pleasure that I introduce Rob Hope and Ryan Coleman from Ecolighten Energy Solutions. Ryan is co-founder and CEO, and Rob is senior consultant, and we are really lucky to have their knowledge and expertise here today. So I will pass things over to you, Ryan.
And partner with us. And yeah, and I'm thanks, Jenna, and happy to have, this is usually Rob's session. And I know he's done a bunch of these with Community Energy Association, and the last one we did was myself and Hazik. So we're going to build off of that one and spend a little bit more time talking specifically about ductless heat pumps. I'm totally fine with questions as we go, Jenna. So if folks, and I think Rob, you're okay too. If people ask as they go, we can just address it during the presentation. So folks, we're going to do background on manufactured homes. So similar to last time around, we'll talk a little bit about what manufactured homes and what the market looks like. We're going to spend some time specifically talking about the energy upgrade potential with manufactured homes. So there is significant weatherization and mechanical system opportunities with manufactured homes. The lens we're going to use today is with utility programs. So utilities have been doing a lot of work with ductless heat pumps. So we're going to go through some participant feedback, the process with equipment sizing and installations, performance verification, common barriers and solutions with both participants, homes, and parks. So you're going to find that manufactured homes are very unique and they come with their own challenges. And so we want to unpack a little bit more about specifically what are those barriers and solutions. And then we've actually started some pilots with centrally ducted heat pumps as well. So we're going to touch a little bit about how those pilots are going and what the opportunity is with forced air systems and putting in centrally ducted heat pumps where there may have been a previous electric furnace or gas furnace or oil furnace. And then we'll finish off with some key learning and questions. So what is a mobile or manufactured home? So I guess just starting from a starting point, the industry itself has really transitioned away from using mobile as the identifier of manufactured homes. So suppliers, associations, and all are defining them as manufactured homes. And there's actually a definition for the structure in the BC Manufactured Homes Home Tax Act, which is a structure whether or not ordinarily equipped with wheels that is designed, constructed, or manufactured to be moved from one place to another by being towed or carried away to provide a dwelling. Typically, once in place, you'll find these structures on concrete blocks and sometimes on concrete pads or sometimes on dirt. So they are on more permanent foundation, but they are transported to site. And that's important to keep in mind when we talk about the energy performance and where these houses may be designed. And typically we're going to be installed and then end up in places like Prince George where they may not have performance attributes for that type of weather condition. Also keep in mind this is not a modular home, or often called factory built, system built, or prefabricated home. Contextually in BC, so for those who are interested, there is a manufactured homes registry that keeps detailed ownership and location information on 84,000 units, which are most of the units that are in BC are in that registry. They estimate that it's approximately 80% natural gas, 20% electric. There still is a lot of like propane and oil homes as well out there. So those are just sort of like rough numbers. In terms of ownership structure, they're usually located either on parks or independent private locations, with parks being the dominant location where these homes are located. So there's 360, the Manufactured Home Park Owners Association Alliance of BC. Well, it's quite the acronym. It has it represents over 360 community park with 60,000 households in those parks. So we work with them closely through the programs that we're going to be talking about to do the type of retrofits that we're doing, both weatherization and HVAC related. And then from an ownership structure standpoint, the homeowners of the manufactured homes, when they're on these parks, they typically rent the land from the park owner. So when we're doing upgrades, and we'll talk about this in the presentation, you need to work with both the owner of the home itself as well as the park owner to help facilitate some of the work. And we'll talk about the nuance between the two of those. So types of homes. So manufactured homes are typically come in two different configurations, single wide and double wide. I've been in hundreds of these structures now, and I can confidently say I've not been in one that has not had some level of renovation and addition work done on it. The visual here on the side shows an example of that. These can be like entryway additions, they could be office space, they could be work areas, they could be living rooms, but all of them have had typically some level of work done that was not the original manufactured home that was constructed in a that was constructed originally. Configurations and layouts. So with manufactured homes, so this is really important when we're talking about designing systems, which Rob and I will talk about here shortly. With manufactured homes, so there's a lot of different layouts, but most of the single wide and double wides or single wides in particular that we've encountered, they usually have a common layout of like a living room, kitchen space that's up front, and then there's a narrow hallway that you walk through that'll have your services and your bathroom and your laundry room, and then maybe one or two bedrooms in the back. The double wide configurations are a lot more complex and difficult to try to heat, especially if you're looking at trying to do one air source heat pump, especially without any sort of supplementary. You're dealing with a much larger structure, and from a design and configuration standpoint, it's difficult to manage the air and the flow of heating and cooling through the more complex structure. So we'll spend some time talking about double wides as well. Heating systems, it's really important to ground yourself in like what are the existing heating systems that are there, because this was quite enlightening to myself in terms of what I thought we would see versus what we actually saw. So just at the outset, we've worked on houses from as early as like 1960 to the 2010s and everything in between. And depending on the age, the condition, the location of the manufactured home, they may use one or more fuel sources to provide both primary and secondary heating. So we've seen houses with oil, with gas, with propane, with electric, with wood. We've seen houses with an oil tank and a decommissioned oil furnace that now has like electric baseboards installed, and various other types of configurations. The way we like to sort of look at it by definition is with these houses in particular is fixed systems and non-fixed systems. And so what I mean by that is like fixed systems are obviously the ones you're not moving around. They typically come in like an electric furnace. I've seen a lot of like wood stoves, especially in additions. You'll see that at like the entryway of the home in remote in particular communities, be it in the Northern Island or in the interior. Wall cove heaters, so still resistance heating, those are quite prevalent in these homes, as well as baseboard heaters. And then with non-fixed systems, this was the part that was like quite enlightening, is seeing the number and the volume of plug-in heaters that we find in these homes. And so a lot, like especially when they've done switching off of, because some of the parks are moving away from oil, as folks probably know on this call. So they'll decommission their furnace, and what they'll have done is they'll plugged in various space heaters around their home. And I've also seen in the most sort of lack of a better term, dire cases, um, uh, folks who have actually been using their stove in the morning to try to heat up their house to provide some additional heating. From a performance standpoint, so those are the heating systems. From a performance standpoint, they have a variety of issues around energy efficiency, occupant comfort, and health and safety. So just to go through the list here, they're always under insulated. A lot of the insulation in these homes is underneath in the underbelly and road barrier, and there's very little to no insulation typically around the walls, limited attic, like to no attic space. So insulation in the roof is very, 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 very limited as well. So the envelope performance is quite poor. They also typically don't have, like we see a lot of single pane aluminum frame kind of windows, which are not great for keeping heat in. So the glazing aspect of manufactured homes is quite poor as well. We do see a lot of moisture issues, especially in like the crawl space, for lack of a better term. So we're having to put in like moisture barriers and things like that. And I touched on it earlier, but the heating systems are usually, old oil furnaces or old standard mid efficiency gas furnaces, or plug-in heaters or electric furnaces. You'll see in a moment here as well, for houses with forced air systems, due to the nature of like poor construction and then transportation to site, we find that a lot of these homes have ductwork that is quite compromised, like collapsed ductwork, or disconnected from registers. We'll find holes in ductwork, and so a lot of the heat is just escaping at the nearest place and then just going out through the bottom of the structure, and definitely not making it to the room it was intended and it was designed for. And then lastly, from an air leakage standpoint, we spend a lot of time doing advanced draft proofing, and draft proofing plumbing, like all penetrations and throughout the envelope to mitigate the infiltration that happens in these homes. So to give you a better flavor of that, here's a few selected examples of the type of existing conditions that we run into when we're working on these homes. So on the left side here, you see these holes in the ductwork, in the distribution system. Here's a completely collapsed duct that had to be repaired as part of the work. The registers disconnected, and as well as not sealed. So we do duct sealing, which we'll talk about here, to improve the distribution system, as well as cutting in from underneath to repair some of these ducting when we can. Here you see a variety of services going out to the exterior and the air sealing done. Underbelly. So this is the subfloor of the structure, the crawl space. Here's the concrete blocks that I was talking about, and the road barrier here has been compromised, and the actual insulation itself, holding in some of the services, has come apart, and the insulation is falling down. Here's probably the most egregious case we've seen, where almost all of the bad insulation was falling out. I don't have the after photo in this presentation, but if you check the previous one that we did last month, we completely took out all that insulation and we put in Rockwell insulation to make that had a dramatic improvement in terms of energy performance and overall occupant comfort. Right, but you're hearing from me here when we were doing this project, particularly with the ductless heat pumps. We wanted to get a really good qualitative understanding from folks about what their experience was with the home performance of their home, so that we could do not just a utility bill analysis on what the energy savings were, but what was the perception in terms of occupant comfort, health, and performance of their home, both before and after. So, and how did you heat your home? This lady was like one electric fireplace in the living room, and then she has two dogs that sleep with her in the bedroom at night, and she had no heating in her back bedroom, and just one electric fireplace up front. I actually remember this. This was a lady early on in the project that was lived in a small park near Hope. How satisfied are you with the comfort of your home? My home's not well insulated. We hear a lot of this. It's a furnace. It's boiling hot in the summer and a refrigerator in the winter. Oh, I should have mentioned, we do see a lot of cooling. So a lot of like window shakers and portable air conditioners plugged in around the houses. Refrigerator in the winter, very drafty, no insulation in the walls, and I'm sure there isn't any. Do you have any comments relating to the heating systems or cooling systems? Again, I'm very cold in the winter. I'm very uncomfortably hot in the summer on hot days. And then, just general satisfaction in terms of your primary heating system. Very dissatisfied. Baseboard heaters do nothing. This is a good example of the uh, extreme costs in terms of utility costs for these houses. So $1,500 in the first 4 months of living there. Very dissatisfied. The good thing was we were able to intervene here before she invested in a pellet stove, and we were able to put in a ductless heat pump. So you can see this is just a sampling, but I can tell you that this is pretty common currency from the folks that we've talked to about when they talk about their structure before some of the home improvement and home performance upgrades that are done. So types of upgrades. So both BC Hydro and FortisBC, both FortisBC Gas and FortisBC Shared Services Territory support the Energy Conservation Assistance Program, which is the lens that Rob and I are going to be talking to you about. So this includes a combination of enabling work as to facilitate energy upgrades to improve the performance of manufactured homes. So last time around, we spent quite a bit of time talking about air sealing and road barrier repair and underbelly insulation and ventilation and minor home repairs, putting in moisture barriers, doing duct repair and duct sealing, doing dryer vent insulation and waterline insulation under the home so that they don't freeze up. High efficiency furnaces have a lot of high efficient furnaces have been done as well. But today we're going to talk about ductless heat pumps and centrally ducted heat pumps. However, we do look at the house holistically, and we try to do the weatherization work prior to doing the mechanical systems upgrade. So it's very much a envelope first approach to the program. So a little bit more in depth. So in 2018, this was when they actually started piloting this weatherization work in manufactured homes. So we wanted to understand the feasibility as well as the technical requirements for doing insulation, high efficiency furnaces, air sealing, because there is no standard of work specifications out there. There is no real good technical guidance on how this work gets done, nor the capacity of folks out there to do the work, which we'll also talk about. In doing that work, we found that the electrically heated homes, we weren't able to do as much in terms of upgrades and energy efficiency and energy upgrade improvements. And we found that they tend to have a much higher electricity energy profile versus other housing types. And they also have from an income qualifying standpoint, it tend to be lower income demographic. So we wanted to find a solution that we could facilitate that could help out with addressing those issues. So ductless heat pumps was identified as a really good opportunity. And so ECAP in the last couple of years has transitioned to implementing ductless heat pumps in manufactured homes and getting a better understanding of what the energy savings costs are, customer interest and acceptance. And we'll talk about some of the barriers and acceptance in a second. And there's been over 100 installs completed to date, primarily Vancouver Island and Lower Mainland, and a few in the interior. We're just getting into the colder climates zones now, because those come with their own unique challenges in terms of the amount of heat loss and just the need for supplemental and backup emergency heating. So yeah, that's sort of the program context. Now I'll just talk about the approach. And you'll, for those who've attended these sessions before, this is very much in line to the philosophies that Rob and we talk about when it comes to doing this type of work, and especially when it comes to mechanical systems. So it's again, it's around proper equipment sizing, proper equipment selection, facilitating a good quality installation, and then getting the performance verification in the end that the work has been done correctly. So the way we do this with the program, and we'll spend some time talking a bit more details. It all starts with a initial home evaluation to determine eligibility. The second step is to do the equipment sizing and selection for the actual project. The third step is to facilitate the consent documentation, be it from the homeowner or the park, and then the doing of the work or the installation and what supports the contractors to that part of the process. Performance verification is the fourth leg on the stool here, where we verify the install performance of the equipment and making sure that it's optimized in the field, both from a control standpoint, homeowner education standpoint, and commissioned properly and checked and documented, I guess, is the last thing I would say there. And then the last thing on the program is we also do a quality assurance visit, which I'll spend a bit of time talking about what that looks like as well. I don't know if we've had any chats or questions come up, Jenna, but I can pause if you like.
We actually just had one just as you said that.
Oh, there we go.
Gail asked,
said.
yeah. Gail asked if you could demonstrate how to clean or replace the air filters on the heat pumps.
You know what? I took I do have some stuff. Yeah, we can talk about that at the end. That is we do a as part of the performance kind of like verification and closeout with the contractors. They take out the filters in the units and show them how to like vacuum them out and clean them. We do, as part of our quality assurance, we go in usually a few months or so after the install, and one of the things that we check for is that filter being regularly cleaned, and we find that many times it's not, and that's such a key aspect to maintaining the equipment performance longevity of the systems itself. With the ductless heat pump units, it's so easy to pop the filters out and to clean them. I don't know if there's anything you want to add, Rob. I can't see you, so let me know.
No, you got it all there, Ryan. I think the critical point is that this is something that should be done directly with the homeowner. Yeah. Like we shouldn't be showing you who are listening how to do this, replace or clean a filter. That should be done done at the project with the homeowner, and that's pretty critical.
Yeah, the controls, the service and maintenance, and also the we'll talk about it shortly, but making sure that the outdoor unit is clear from debris, all that sort of stuff is part of the homeowner education that happens as part of the process. Okay, so the evaluation. So the evaluations of these homes is quite structured in terms of what were the approach and also the documentation. So it's around eligibility, and that includes it's holistically. So as I said, we're looking at the building envelope, any sort of enabling work, and then obviously the ductless heat pump stuff specifically. So we gather information on the age, the size, the configuration, the number of rooms, the layout that may inform like what the design solution is. Details on the existing heating system, both primary, secondary, and what's being used, how it's being used. Are they using cooling? Do they have how often? Health and safety limitations. So we're checking for mold and moisture and other potential limitations that may impede work proceeding. They also the contractor is not involved at this point yet, the HVAC contractor, but the evaluators are trained on sort of looking for ideas of where we could place outdoor units for proper clearances, as well as for aesthetic considerations when it comes to like what parks want to see and things like that. And then where's the best way to run refrigerant lines to the indoor unit? How does that match up against where the electrical panel is located? So there is some strategic thinking that's done early on with an eye towards the heating system replacement. And then with forced air systems, we're actually doing some other stuff in terms of sound checks, in terms of, because noise, we like to document how noisy the pre-existing system was before we put in the post, to make sure we're managing folks' perception of equipment getting louder and things like that, especially with the ductwork. We'll talk about that, I guess, more when we get into the centrally ducted heat pumps. But yeah, there's lots of sort of information that's gathered at this evaluation stage to both to inform the solution as well as like planning for ultimate outcomes in commissioning and verification. And then electrical panel and service. So folks are doing a look at, you know, what is the service, what's the mains of the panel look like? It is 100 amp, is it or is it less? We've seen a few 200 amp panels actually in these houses, but that's very, very infrequent. And then we make sure that all the evaluations are documented. So this is just an example of the hard copy form where we may not have cell coverage, but there is an online evaluation form that mimics this, that gathers all the data and helps with determining program eligibility. So once that's done and we say, great, this house is a good candidate, the participant's a good candidate, the park's a good candidate, the next step is around the equipment selection and sizing. So anybody who's attended these sessions or seen presentations, the load calculations is non-negotiable. And so we make sure that all projects that are receiving a new mechanical system are getting a block load calculation using the F280 methodology and with compliant software to inform the equipment selection and sizing. So it's the HVAC contractor's responsibility for completing the load calculation and providing the ductless heat pump sizing, as well as we ask them to provide any recommendation on if and where they think supplemental heating may be needed if it's not present, or if it's required. So we're getting some of their design input as well. So the evaluation information helps to inform those load calcs, and then those are, for lack of a better term, kind of audited by the program to make sure some of the things that I know Rob's talked about in previous sessions. You know, what are the design conditions that have been put in there? What's the location? Some other things that are checked to make sure that the loads make sense. We don't recalculate; we just audit some of the inputs to double check things. And then the equipment performance requirements, they're pretty much in line with the for those who are familiar with the program qualified list. I think it's called the PQL or whatever, that for the Clean BC Better Homes program. We have a couple small tweaks just in terms of raising the bar slightly in terms of performance levels for the program itself. So it's a slightly smaller list, I would say, than what's available on the program qualified list. Consents and installation. Right. So this is the third step. So we've got our loads, we've got our evaluation, we're good to go in terms of facilitating an installation itself. Before we do anything, we make sure that the homeowner signs off on what to expect in terms of the process, the installation, the equipment details, any sort of like compromise, I shouldn't say compromises, but like enabling work that may have to happen. We just want to make sure that that's really clear to them. The park owners, if they are in a park, we get the park owners to consent as well. So typically we're addressing where it's going to be placed, how we're managing noise, clearances, that kind of stuff. And we have the park owners sign off on it as well. This last piece, standard of work specifications. So there is no standard of, if you do a Google search, there is no standard of work specification for a ductless heat pump. The program has developed their own. And we do this for all the measures. And the objective there is to provide as much technical guidance to the contractors as possible to ensure a good quality installation as the output. So at the highest level, we make sure that the specification aligns with the requirements of the equipment manufacturer and the authority, like any authority having jurisdiction. But then we provide additional prescriptive sort of direction on best practices. And so we typically will reference sources like TECA, HPS, Home Performance Stakeholder Council, or HRAI, or other jurisdictions doing this work, where things that we would like to see to make sure that we're putting in good quality components around just the great equipment that we are the high performance equipment that we're selecting for the actual install. We provide some direction on sizing and supplementary or backup heating as well, so we'll help them with decision making around that, and then also installation support. So dealing with building penetrations, how do we want those sealed? What type of conduits do we want to have used to facilitate the refrigerant lines into the structure? When and where do we use debris shelters? What's the snow clearances? How do we mitigate noise? All that kind of stuff is there to support the contractor through the work, as well as when we go out, when the program goes out and checks. We want to make sure that we have something that we're checking against. So the quality assurance is against that standard of work specification, and the contractors participate. The contractors that are on the program, we get them to participate in the development of some, or give some technical input on the specs. Fourth piece, performance verification. So we want to manage sort of like the tasks and activities and make sure that everything's documented through the program. So the contractors themselves have a task, what's called a task completion form. So they detail out, like, the results of the heat loss, heat gain. We get them to diagram out the indoor and outdoor unit locations, just a simple like Venn diagram of the structure, where they see the routing and things, any sort of electrical permit details, provisional work. So was there any enabling work, like a energy panel upgrade or otherwise, that had to be done to facilitate the ductless heat pump, and then confirming that all the homeowner education, some of the stuff that we were talking before, was completed. So that's the responsibility of the contractor. And then the last step, as I mentioned, is the quality assurance component. So the usually around houses, like each of the houses gets either a virtual quality assurance visit or a field visit from the quality assurance personnel in the program to review the installation. So when we are able to, we'll facilitate virtually with the participant, if they have a smartphone, to walk around their home inside and outside, to have a look via iOS FaceTime or Android devices, Google Meet or otherwise, to check out the install, ask some questions about their experience with the program, the experience with the contractor, and then checking the systems. And so, and then auditing of the files, where they, as I was saying earlier, was the inputs used for the load calcs? How do those check out? Is the evaluation, the mandatory information from the evaluation in there? And if not, is there any like compliance or non-compliance? Because then that all gets reported out to the programs, and again, and to the contractors. And the objective here is for peace of mind for all stakeholders. So the park owners, the homeowners, obviously the utilities and the program funders and supporters of this, and then the contractors themselves. We want to make sure that they have positive feedback loops, that the time and effort that they're making to do these systems is that they're getting good positive feedback around the install performance and their participation in the program.
Ryan, we do have a couple of questions that came through about those steps, if
Perfect.
you don't mind.
Go ahead.
Richard asked, are there any issues with louder cold climate heat pumps and closeness to neighbors?
No. So the heat pumps that we're selecting have low decibel ratings, and one of the things that we do up front is we have like I should have left it in here. I had a visual diagram where we show various other noises like refrigerators like outdoor ambient noises that are louder than the actual heat pumps. And we've actually recorded some of the heat pumps in like full operation, like at full, to show those that the program delivery agent will show those to the park owners to get them an idea of like how do these actually sound. So we've been able to really mitigate some of that, because the challenge has been is that older the reference point for a lot of these park owners is older heat pump technologies or existing air conditioning units that are really loud are there. So they're naturally and understandably, their initial perception is that these things are going to be really noisy. And then you'll see in some of the videos, when we install these in on the pads and things, we're incorporating things like waffle pads and other measures to sort of mitigate vibration and stuff, to try to manage the noise. But at the outset, the heat pumps that we're selecting have sort of the lower decibel ratings. Rob, I don't know if you want to color in some additional technical context there.
Yeah, with the cold climate heat pumps, they're new-ish technology, and so in addition to efficiency and capacity at sub-zero temperatures, they've also incorporated variable compressor technology and so on, which is inherently quiet. So cold climate heat pumps typically, by their very nature, are quiet heat pumps. And you look at initial decibel rating, typically between 55 and 60 decibels. That's, at the high end, that is, that's hard to hear. When you're standing by them, you almost have to listen carefully to see if they're running or not.
Exactly.
And especially, it's important to know that whatever that decibel rating is, decreases not in a linear fashion, but in an exponential fashion as you get further away from it. The amount of decibels disappears in large increments.
Yeah, that's a great point. And we do our best to try to, from design solutions, to locate them, like so that we're from an aesthetic standpoint, like that's one of the things that manufactured home parks are concerned about. And then obviously the neighbors complaining about noise. So hopefully that answered that question. That was really good.
Thanks. Yeah, and Richard just pointed to the commonality between that and heat pump adoption in stratas and condos. So thanks for that, Richard. And Freya asks, is the F280 load calculation for the whole building or room by room?
A whole building. Sometimes, it's for the whole structure. We're not changing out ductwork and things. So we're not trying to design a new system into the house. We may get them to, like, in some cases, like if we only think that the heat pump is going to be able to really service a certain part of the structure, we may get them to separate out like a bedroom or something like that. But our common ask is that a block load, so the entire structure is taken from an F280 standpoint.
Great. Thanks, Ryan. Perfect. And Freya says thank you too. All right, that's all the questions we have for right now.
Awesome. Okay, so barriers and solutions. So there is a number of sort of considerations, like they're called barriers, but we can work through each of these. But we wanted to touch on kind of three in particular. One is home compatibility. Second one is just the electrical challenges, and then the third one is dealing with manufactured home park rules and ownership structures. So we're going to talk about each one of these individually. So from a compatibility standpoint, as I mentioned earlier, like depending on the type of manufactured home, if it's single wide, double wide, the design configuration within the home, so where the home rooms are located, whether or not additions have been added, are those additions separately heated? There's a myriad of considerations that you need to figure out when you're developing a design solution for a ductless heat pump. And so the way that we go about it and the flexibility that we give to the contractors is to customize. And so they have options to put in multi-head ductless heat pumps where required, be it from a BTU standpoint or design standpoint. We also allow for ductless heat pumps as long as like 85% of the house is able to be serviced, to have supplemental heating provided by like in the back in the back bedrooms on separate controls, obviously. And then we also have installed, in some cases, fans in the house to help with some of the airflows from the ductless heat pump in the home to facilitate better distribution. Rob, I don't know if you wanted to. You had some good anecdotes yesterday when you and I were chatting with work with like Sam Zernhelt and others, where you've put in ductless units in these types of structures or others like this type of application, I guess. And what you kind of think about from a design standpoint. Would you want to share some of that, maybe?
Yeah. So as you can imagine, I don't know if you remember the diagram of a typical um, plan view. You know, you've got the living,
Yeah, go back. I'll go back.
dining, kitchen. Okay, sure. There we go. Yeah. So as you can see, you know, if you're going to put a single head in, you want to put it in the room where you're occupying awake time most of the time, which is going to be your living kitchen area. So that's where you'd want to put if you're going to put a single one in there. That single one may have the capacity to do the whole building, but that head, the air from it doesn't like to, you know, go down hallways, you know, make hard right turns, open doors and go into other rooms, right? So you're going to, in both cases, in this diagram, you can see the master bedroom end of the building. You may not have put in a head there, might not warrant it because of the load and cost and that kind of stuff. If that's the case, that's where you put your supplementary, put some baseboard in there. You can expect that that heat pump that is in the living room is going to incidentally heat the back area of the house, the opposite end of the house, but not to the degree that may satisfy your desired thermostat set point. So that's where you put the supplementary heat, the baseboards and so on. And this is a common practice in newly built modular homes, you know, factory built site assembled, for example. That's very common in very cold climate areas in this province. That is a strategy. If you can, however, if the master bedroom is large enough with windows and a significant load, heating or cooling, but a multi-split. So you put a head in there. The only issue is you got to be careful that you're not putting in a head like a ductless unit that is oversized, and that can happen in this situation when you have manufactured home. Even though the master bedroom is big, the load might be smaller than the smallest unit you can get on the market, right? So you got to be careful about that, but it's possible to do that. And then there's other mitigation strategies that Ryan just mentioned, like having a fan moving air around the building. You can have transfer grills, you know, you can depend on the half-inch undercut of the doors for air transfer between rooms, but you can also put transfer grills to help with that as well.
Nice. I'll get us back on track here. There we go. Okay. Electrical in the home. So barrier number 2. So this is particularly challenging where the manufactured home was originally designed with an oil or gas furnace, because those ones, with the main appliance, oil and gas, the electrical requirements were lower. So we'll find like the panels, that's where we'll find like 60 amp, 70 amp panels, which limits the electrical capacity. So the typical issues that we encounter here are less than 100 amp service and panel. And that, like I said, those are typically found when it's a non all electric home. When it's an all electric home, we've been relatively more successful in being able to manage sort of the capacity at the home. The other things we'll find are like there may be limitations around the number of breaker slots available. And then with older, some of the older panels, we've found that even if they have a slot available, that slot is sort of like damaged. So we got to do some enabling work to to be able to facilitate. So some of the solutions, and then I'll get Rob to touch on this more detail, that we've incorporated through the program is we'll replace the we'll replace the electrical panel where we have to, or also if we're switching over things and we're not having to use a lot of baseboards, we're able to use that for the heat pump. So we're disconnecting some of the systems that were already there, and then in a couple handfuls, we've actually piloted an energy management system that's been primarily used to date with EV charging, but basically connecting multiple loads to allow switching. And the device that we've used has been in both cases has been a dryer. So switching between the dryer and the heat pump to increase the service capability when there's limitations. Do you want to chime in, Rob, with any sort of energy management and electrical?
If you think about it, if you've got a building full of baseboards, electric baseboards, you've probably got enough capacity in your panel already if you're going to be removing all or a majority of them. The amount of electrical capacity those baseboards are using on the panel are probably at least equal to, or if not more than, what the heat pump requires. So that's something to keep in mind. The load management is basically a priority switching, right? So just think about your dryer. It only comes on intermittently. It's not that often. It comes on, it's finished its cycle, and then your heat pump can come back on. So it's just priority switching as opposed to adding load to the panel. I think that's all I got.
Perfect. Yeah, that's okay.
Particular subject.
Yeah, no worries, no worries. And then the third barrier, manufactured home park rules and ownership. So as I mentioned, we were talking earlier, we showed that slide. There's about 84,000 units on the registry, and then there's 60,000 or so that are in the actual park owners, and like a few 300 or so parks. So the people who live in those parks, this is a sort of an example diagram of one of the parks that we worked with. They don't own the land, they rent it, and so they need to follow rules under the Manufactured Home Park Tenancy Act, and so it gives the park owners significant rights and power. So their approval is definitely required for installations. The typical things that we've encountered with park owners are visual aesthetic concerns with the equipment. So they want to be reassured that they're not going to have a bunch of like what they perceive as eyesores in the park. They have other tenant sort of concerns with noise and neighbor complaints with the systems itself, which is understandable because they've experienced that. And they've also have sometimes have park electrical capacity issues. So as you can imagine, they're getting their service in from hydro from the street, and then they typically have a bank of meters or a meter room, and then it's subbed out to the individual units. And the concern there is that if these heat pumps are coming in, that they are going to trigger a call to BC Hydro and a very costly sort of service and capacity upgrade. And we found that the manufactured home parks are not necessarily interested in investing in improving that infrastructure. So we try to work with them in terms of the number and what it means in terms of putting in the heat pumps and eliminating some of the loads elsewhere. So the solutions on this, so we have education materials around equipment decibel levels, the one that I was referencing that gives examples and information on comparisons for minimizing noise. Again, we also have mitigation measures to help address that. We try to design intelligently to limit the visibility of the outdoor unit as much as possible. We're try to be elegant with the routing of refrigerant lines. So we'll have some photos here to show you, but trying to run those either underneath or at least matching conduits to the home. So just making sure that they are we're going to get performance, but as well as aesthetics. And then we use consent forms to manage the expectations. So here's some examples. So you can see here, this is an outdoor unit, and this is the refrigerant lines with UV protected, insulated, running into the conduit coming into the home, matched to the siding. Indoor unit, filter obviously in here. The outdoor unit, so use of the pad, and then you can see there's the waffle pads here underneath the feet of the.
They're to absorb. Sorry, Ryan. Just waffle pads for those who don't know what that's referring to. They're rubber sandwiched or cork sandwiched with rubber to absorb vibration.
Yeah.
So they're just little inch and a bit tall rubbery pads that go under the legs of the unit.
Yeah, they cost virtually nothing, and they're great for managing performance and mitigating noise, as well as raising the unit off the structure. Here's some more pictures. So a good example. So just using just raising up the unit, especially in colder climates, for like snow levels and things like that. We try to do. Again, we use the waffle pads here, electric panel labeling, indoor unit. So yeah, so let's circle back here before we get into the key learning. So what's the feedback been since after upgrading the ductless heat pumps? So lowering energy bills. So, works great. It heated up my home in 30 minutes and lowered my bill by $250. I should have gotten one years ago. This one, healthier homes. Technology like this is helping seniors like me stay in their home longer instead of moving to assisted living and living longer, healthier lives. We've found that the healthier home piece is a big one, like the actual occupant comfort, and like going back to see folks from like our first visit where they'll be wearing like a jacket in the house to being like much more just comfortable and both in the indoor environment and just their demeanor. Like you can see the benefit that these are making, other than just saving some money and energy. Improve comfort. The ability to get to higher set points and a warmer indoor air, warmer indoor environment. And then energy efficiency, not using my electric fireplace anymore. My home is much warmer. We have seen that the energy bills in the summer, for those that weren't using cooling previously, like we do try to let them know that if they are going to use the heat pump for cooling to provide that comfort, that you may see your bill go up, but we haven't had any negative feedback really from homeowners to date on the cooling piece. The only issue we had to resolve a couple months ago was a lady in Campbell River. She was running her heat pump and her air conditioner, her two window units at the same time, and so we just had to make sure that she understood that that the heat pump could more than adequately cover the cooling for her home. So a little bit of additional homeowner education, we were able to address that. But when we went in and looked at her load profile, the summer issue was there, and but when we unpacked that, we could clear that up pretty quickly once we spoke to her. Ducted heat pump. So yeah, so before we talk about ideally, when we have forced air electric furnaces, the ideal solution is to go into the house and replace it with a centrally ducted heat pump. The challenge with centrally ducted heat pumps really comes down to the ductwork condition and capacity, and especially in older homes. Like we found that when we were retrofitting mid efficiency and standard efficiency gas furnaces and putting in new high efficiency gas furnaces, which have an increased CFM, that we had to do some mitigation measures and duct enhancements and duct sealing and other sort of like work to make sure that that equipment was going to perform. And so that is amplified when it comes to putting in central heat pumps, which operate at an even higher CFM. So we are starting to trial these with a handful of jobs. And we've been targeting kind of like newer-ish manufactured homes to try to build confidence, as well as, again, we're starting from scratch a little bit in terms of building out standard of work specifications. So we had a house with that already had an electric furnace and central air conditioning, and we replaced it with a central heat pump, which I'll show some pictures. So on the duct sealing side of things, so before we do any sort of work to replace the equipment, like the first thing we do is to try to improve where it's accessible, and where we need to the actual duct work to try to ensure that the forced air heating reaches the location it's supposed to be distributed to, as well as just better managing the static pressures and the capacity of the ductwork. And so we do interior duct sealing using mastic and sealing the registers from inside the home, which is helpful. And then we also do exterior duct sealing, where we will cut into the road barrier, access like collapsed ducts or compromised ducts, and then fix those and then seal it all back up. So it's quite a significant piece of work. And we have a performance testing methodology, pressure pan testing, that helps us in terms of triangulating where the leakage may be. So they're not going in blind when they're underneath. They're able to kind of like isolate the area where we think where the ductwork is compromised. So this is some examples. So here's some of the duct sealing that has been done using the mastic. Here's just a physical example of like the types of conditions that these folks are working in. The Herculean efforts to like, get in under here and cut into these road barriers, insulation falling on you, trying to find the compromised ductwork to get in there to repair. It's very labor intensive and in somewhat confined spaces, let alone some of the things you might find when you're underneath a manufactured home. This one's in relatively pretty good shape. And then this is just an example of some of the pressure pan testing at the register to try to help with triangulating where to go to help with the duct sealing. So here's the after photos. So this was the old electric furnace and coil that was taken out. Here's the new air handler and heat pump system with accessible filter rack here, outdoor unit, again, pad, waffle pads, conduit, ceiling. We try to facilitate these installs with 4-inch pleated filters to again help with the static pressure issues, as well as provide better indoor air quality. And the replacement of the filters is less when they have more surface area too. So we try to put in better, and they have higher MERV ratings. So the MERV rating is like the level of particulates. The level of particulates that can be filtered out. So we're able to put in high efficiency filters with thicker pleated with higher MERV ratings, and then matching thermostats wired correctly. So putting in new thermostat that's optimized with the equipment. Okay, so quickly on the sort of like the key learnings from the work to date. So number one key learning is I think you probably got a flavor for is that these are very much a unique home type, and there's no standard one size fits all solution for manufactured homes, and that's just the nature of the construction, their configuration. They, other than more recently where you have a CSA Z240 standard, these houses really didn't have a performance standard that they were being built to. And they may have been like designed to be located in Arizona and end up in Prince George. So those climate conditions and impacts with the house can be quite extreme. You see issues across both single wides and double wides. As I mentioned, we try to take the envelope first approach, so reduce the heat loss to get a better outcome, and then size the equipment accordingly. We are able to facilitate minor home repair work. So as I mentioned, moisture barriers, duct repair, and all that stuff is done to try to facilitate the advanced upgrades and address some of the performance issues and get to better outcomes. Customization, so they all require, again, some level of customization with ductless heat pumps, and that's again due to the inherent nature of the housing type. So Rob and I talked about the challenges with single wide, double wide configurations. Is there an addition or not? How is it included in the heat loss? Is it got something else like a wood stove there? Regional location and needs. So the thermal performance of the building may not even work in climate zone 4, let alone climate zone 5 and 6, where it's been transported to and located. Do they have fixed or non-fixed or a combination of heating systems? And then the amount and type and sizing of supplemental backup that may be that may be needed, especially when you get into colder climates. Like the heat pumps we're putting in will work down to low temperatures, but you may get into situations where you need 100% sort of backup heating and things. Sizing and selection. So we've developed standard of work specifications and approaches to ductless heat pumps, and so that's been one of the great benefits of the program. Participants in colder climates, as I mentioned, especially in climate zone 5 or greater, they do require larger BTU sizing. So you need to be considerate of what the supplementary backup heating might be needed with the heat pumps, depending on size and location and things like that. And then the existing issues with poor ductwork can create challenges with heat pump sizing and selection to achieve optimized performance. So that's, we're sort of walking before we run when it comes to the centrally ducted units. We're still really going to be learning about how to best do that in these homes. Key learning number 4, specialized work. Yeah, so like I mentioned this in the previous presentation around weatherization, but it's pretty consistent across the mechanical systems as well to a degree. The capacity to work on manufactured homes is a lot more limited when you compare that to contractor capacity for single family and ground oriented Part 9 type structures like townhouses. There's no specialized contractors who just do this work for manufactured homes. Like the utility programs over the last sort of a decade or so have built up the capacity, and we actually leveraged for those who are interested in getting further into the type of work being done on manufactured homes. I would encourage you to look at the Bellingham Building Performance Center. And if you want to reach out to somebody in particular, their gentleman's name is Chris Clay. He's written standard of work specifications in the United States, and he's probably one of the the real leaders. Rob to us in HVAC, Chris is to manufactured homes in the United States. So you'll be getting a real expert in that type of work down there, as well as the Renewable Energy Laboratory, RWEL. They have standard work specifications as well that are for manufactured home retrofits that we actually leverage for our work. There are no standardized technical specifications or permitting inspections to guide retrofits and workmanship in this area. So it's all been kind of like net new and developing through the program. And Rob, you'll get a kick out of this. This is Doug crawling out from underneath the manufactured home. Doug's from our team. Some resources for folks. Heat pump best practices installation guide is great. You can access that through the Home Performance Stakeholder Council. It covers off a lot of the things that we talk about, especially on the forced air side. Enercan's heat pump sizing toolkit, if you haven't had a look at that, and their new app that's coming out, mobile app, to help with equipment selection and sizing. I would encourage folks to dig into that as well. And then the LEAP best practices videos. If you go to that URL, they've got a number of videos that talk about heat pump installations and dealing with existing ductwork and sizing, like 5-minute or less videos, both participant experience, contractor experience, really great resources. And I think this week we did a series for manufactured homes with them, and that I think it's coming out this week. The new videos for that, as well as there's a new one from Gary Hamer, for those who know from BC Hydro. He's got one on electrical capacity and dealing with panel constraints and doing heat pump installations. So that's another one that's coming out as well. So quickly summarize before we get into Q&A. So manufactured homes, as we mentioned, they typically underperform in comfort and energy efficiency, and the original design and construction is the harsh reality of these homes, unfortunately. So they perform poorly, but that is an opportunity to improve performance and people's lives. They're unique, so they require customized solutions to address these performance issues. So I would break it down by enabling work, again, weatherization work, and then mechanical systems. And you really, those are not mutually exclusive. You need to think holistically. How does the system kind of approaches to get the best performance outcomes, as well as avoid any unintended consequences that may happen if you like try to take silo-based approaches. Limited skilled and contractor capacity. So, it is specialized work, and it is difficult work. I would say that too, in providing weatherization and HVAC upgrades in manufactured homes. And tools are developing now to improve installation practices. So some of the things, like I said, standard work specifications, checklists, just approaches, testing, like the pressure pan testing and other things to help with identifying where to seal ductwork or repair ductwork. That those kind of things are as we do more homes, we're developing a broader inventory of assets for the community. And then the utility program. So FortisBC, BC Hydro, their initiative and their leadership is really what's led to both initially tackling some of the challenges that are out there, as well as developing the systems and tools and processes to do energy efficiency improvements in this more challenging market segment.
Wonderful. Thanks, Ryan. All right, folks, before we move into the Q&A, I've been noting we do have a few questions in the chat that we can ask Ryan directly. I'm just going to run our poll. If you've joined us before, you're familiar with it. All right. Okay, perfect. We have about a good amount of folks who have responded to the poll, so I'll let that keep going in the background, and we'll just move on to the Q&A here. So yeah, go ahead. I'm going to go through just in order that the questions were received in the chat. If you do want to ask a question during this period, feel free to raise your hand and you can ask directly, or go ahead and pop it in the chat and I'll come to it. So the first question here, Lori just asked, she asked this in the chat, and I was hoping that someone could help her out with this, but I'm not sure, Rob and Brian, if you know of any contractors in the South Okanagan for under home work. I know that you guys are on the coast, but if you're connected to anyone in the South Okanagan who could help out with this retrofitting manufactured homes.
Drop me a note to info@ecolighten.com and I'll we were actually chatting with a contractor like 3 weeks ago.
Perfect.
I might be able to give a name.
Thank you. All right. And then Lori also, she highlighted an issue for us to look at. So if the installed venting is beside water pipes under homes, keeping them from freezing, what happens when ductless heads are used and water lines have no heat from the ducts and the crawl space has no heating, flush is uninsulated?
Well, the chances of pipe proximity, pipe carrying water in its proximity to duct being the sole method of keeping the water pipes from freezing is not likely. It's not, that's not, I don't see the physics of that happening. So I don't think it would make any difference, but it is one of the things that has to be looked at in any case, whether there's ducting there or not, whether there's a whole electric system or not, is when you're thinking about upgrading the performance of the building in general, that's one of the things you'd be looking at.
Yeah, unintended consequences.
Great, thank you. All right. Dave had a question about the federal and provincial grants, and I just got a note from Janet that she could answer this question. I'm not too sure that Ryan and Rob, I'm not super well versed on the rebate programs, but Janet, if you want to unmute yourself. And Dave just asked if park tenancy is a barrier for manufactured homeowners to access federal and provincial grants and financing. If you're there with us.
Good question. I'm not nuanced enough on the eligibility criteria to
Mhm.
speak to that.
All right, well, maybe move along. I don't know,
I
maybe
don't
she's
think
not
there's
on
an
the
issue with
call
the home
anymore.
type. Like I think the home type is fine.
I think it's the question of ownership,
Yeah.
because I know that, yeah. But again, I'm not entirely sure, so I don't want to give my
Yeah.
my thoughts. Um, all right. All right. Well, maybe we'll move along and come back to this question here if Janet wants to jump on. So our next question was thoughts on load sharing devices where existing panel size and or park load availability. Seems some municipalities are okay with them, others are not due to their perceived design use. So any thoughts there?
And, like with this lens, we've only used it twice, and so and we've only used the Divi Load Miser, I think it's called, or something. It's the one that is, I think it's the most common um technology that's being used right now. But the question was specifically around like the municipal um limitations, or
And
do
some
we see
authorities with
potential, or what
jurisdiction,
was it?
yeah, some authorities with jurisdiction don't allow
Hmm.
because the electrical
Code.
code it doesn't incorporate that yet into it, right? So it depends on the municipality or authority having jurisdiction whether it's allowed or not.
Okay,
I do know there's some
perfect.
work. I do know there's some work being done, and I think Dunsky's leading it to look at what updates need to be done in terms of code language and things to help facilitate the load sharing device technology. So they're more, because I know there is some interpretations and challenges there. So the issue's been identified, and sort of there's movement on how do we deal with the solution, but it's not accessible today.
Okay,
So I'd say stay
great.
tuned, I guess. Sorry, I don't, that's not a great answer, but
It's no problem. And I just got a note from Janet. She's back on the call with us. If you want to let us know about the rebate programs, the federal and provincial.
Sure. Okay. So the federal program previously was the Canada Greener Homes Grant, which is no longer available for new registration, but still people who registered before February 11th can use that. There is currently still the Canada Greener Homes Loan. And there may be in 2025 an additional Canada Greener Homes grant program, but who knows? So with regards to tenancy, it's not clear what the mobile home users are definitely able to access the loan if they are on a permanent foundation and if they are the primary resident and they own it. There's a question though, because in order to apply for the Greener Homes loan, you must provide your property tax info.
mm.
And I don't know what that looks like in a mobile park. So it may be that, they wouldn't be eligible because they're not paying property taxes. They are actually paying rent and not the park is paying the taxes. So that's a question I can't answer. With regards to the provincial loans, rebates, yes, you're very likely able to tap those because even renters are able to tap those. There's two different types. There's the mainstream one, and now there is the new energy savings program, which has some income level qualifications, but they're quite high right now. So that should not be a problem. And with regards to the Fortis, no, you can't combine the Fortis and the Clean BC rebates because they're all really the same rebates. They're from the same source. So you would need, unless they're a rebate that doesn't have to do specifically with heat pumps. There may be some quirky ones with Fortis or with Clean BC, but essentially you do need to use one program. That's
Great,
it.
thank you. And we're going to hear all about the Fortis rebates here shortly. So thanks for that.
Yeah.
Thanks so much. Janet works with the Regional Energy Efficiency Program in the RDCK, so she's well versed in the ins and outs of the rebate programs. So thanks for hopping on there. All right, we have a few more questions here and about 10 minutes left. So Scott asks, is it possible to add new ductless unit or heat pump if the required combined F280 loads are smaller than the smallest unit available?
Yeah, to a degree. It depends on how much lower, because as you can imagine, if you do a load calculation, it tells you, you might need a 2-ton system or just under 2 tons. So you would go up to the next size, 2-ton system. There is flexibility in most of these products to a degree. So you have to be careful, and you have to look at the specifications of the product. If you oversize too much, for example, if that back bedroom only needs, a 1/4 of a ton, and the smallest unit you can get there is a 1/2 a ton, it's double the size, the capacity. It's a bit iffy because what'll happen is it'll short cycle, it'll come on and off, and that's not good for comfort, not good for efficiency, and it's not good for the life cycle of the equipment. So it's a judgment call that has to be made based on the data from the load calculations and hopefully some good experience.
Great, thank you. And I see Ryan nodding along there. So great. All right. Cameron asks, do you have any recommendations on thermostats for central ducted systems? Some manufacturers don't seem to offer anything but basic control units with no programming or connectivity.
Oh, that's a big question. We could spend hours just talking about that. So ideal situation, you use the thermostat they manufacture, created for the product. Especially if it's a communicating system, that is your top tier of performance in any manufacturer's catalog of products. Communicating equipment. What that means is that thermostat is designed and ideally suited to take data and put that into algorithms and optimize the performance of the system. In other words, it's part of the system. And then there's non-communicating, which is not part of the system. It's an on and off switch, basically. So it's any third party, like a, so-called smart thermostat, like a Nest or something like that. It's a third party thermostat. And yeah, all of them, it's really hard to find a thermostat that does not have programming capability.
Yeah.
But I would caution that programming capability is overused in a lot of cases and creates a lot of problems. One of the things you don't want to do is set back your temperatures too much. A couple of degrees Celsius max. Beyond that, it's going to create issues, lots of problems for a lot of reasons that we won't get into. But that tends to be an issue with homeowners. And I'm gone to work all day. Let's turn the system off or turn it down 10 degrees. And it depletes all the core heat in the building, takes a hell of a lot of energy and time to bring it back up. And those are issues that are created with programmable thermostats quite a bit. But all good thermostats tend to be programmable, even the manufacturer's thermostats. But they also all have the simple, off and on, non-programmable ones as an option for budget-oriented projects.
Yeah. The only thing I would add is like the interoperability piece is the key thing from a functionality standpoint. Like we see, because we're looking at systems like every day, like 2-stage and modulating equipment with like old mercury-based thermostats. And like that's a really egregious example, but it's more common than you would think. And it's like, people spending, thousands and thousands of dollars and not getting, the functionality of what they were investing in. And it's criminal. So like matching your thermostat to the equipment, as Rob said, and like the manufacturer proprietary, like, It's kind of like your computer. Like Word and PowerPoint work really well with Windows-based computers.
Wonderful, thank you. All right, and we just have one last question here. If I missed a question, if you put a question in the chat and I haven't got into it and it seems I've missed it, just please flag me and we'll move to that question after this last one. Scott just asked, very general, geothermal versus air source. So any comments on geothermal versus air source heat pumps in manufactured homes?
In manufactured homes, no,
Well,
that's an easy answer.
Don't do it.
For if you got an estate,
Yeah.
then yeah.
Or you can convince the park owner to do the whole
park.
Then you can get like, a community energy program going of some sort, and maybe it'll create a reasonable cost benefit in favor.
Yeah.
Right. But generally speaking, the quality of cold climate heat pumps these days, the technology is so good that it is very close to the efficiency of geothermal, with the big difference being that the geothermal has inherently a much higher premium cost because you have to create that infrastructure, whether it's drilling or horizontal loops or in the lake, in the pond, in the ocean, all of which we've done. It's all expensive. And so against cold climate heat pumps with that high efficiency, the cost benefit analysis usually does not come out in favor of geothermal.
Yeah, definitely not this application, other than if they were going to do a whole park, as Rob said, which is a good creative solution. And then even with houses, like unless it's like a very, very, very large home and with very unique needs.
Yeah, even in the largest homes that we've done, 30,000 square feet or bigger, it's still not a cost advantage to put in geothermal. It's usually because they don't want multiple outdoor units in their landscape backyard, and money's not an issue. That's why geothermal goes into those places.
Great, thank you. Richard squeezed one last question, and I think we can get to it. He just asks, what ACH score, so air changes per hour, would you steer away from an immediate cold climate heat pump install?
I don't think it's an ACH score.
No, it's not.
That that contributes to the load, and we in situations where we are not able to get the actual ACH, we put in a very conservative value of leakage for the load calc. So we do not we err on the side of anyways. So
yeah, the other way to look at it is, even if the ACH is greater, that actually is more reason to put in a cold climate heat pump.
Yeah.
Cold climate heat pump is impervious to the amount of infiltration the building has, right? You're going to put in a heat pump in our country, with the exception of, a few places like the Lower Mainland, a cold climate heat pump is always your best choice, regardless of the load of the building. The only difference, the more infiltration will make, you might need more supplemental.
Yeah. And
okay, great. Well, sorry.
I was just gonna say that, like, that's a good, that's the reason why we do the envelope stuff first, like before we do the mechanical.
Great. Good last plug for envelope first.
Yeah.
Appreciate it. Okay, great. Okay, well, that brings us to 9:30. Thanks, Ryan and Rob. Really appreciate your expertise and taking us through all the considerations that come with ductless heat pumps and manufactured homes. We're just going to pass things over to Juan. If you are able to share your screen there and let us know all about FortisBC's rebate program.
Let me know when you can see it, please.
We can see that. Yeah, you're good to go.
Okay, wonderful. So yeah, thanks for the presentation. It was very informative for me as well. And maybe just to reiterate what Rob just mentioned, I think building envelope first is what we also endorse and suggest when looking at renovating a home in terms of heating and cooling. So I'm very excited today to share some of the rebates that we have been working on for the last little while. And just in the interest of time, because I realized this was scheduled until 9:30, I'll go through my slides maybe fairly quickly and give more time for some questions at the end. So I'm gonna briefly introduce why FortisBC does conservation and rebates in general. I think that's something that maybe not everybody is aware of. I'll go over some of the retrofit rebates, which are the most applicable to the conversation here today, but maybe for some of the folks that are in the new construction industry, and maybe mention some of that, as well as we have a brand new program that we're soft launching currently. So, you know, the vision that FortisBC has is to be part of the energy solution, and we have pretty steep targets in terms of greenhouse reductions. Moving forward, by 2030, we have a pretty significant milestone to hit 40% of the emissions from 2007 to be reduced by 2030, and then 80% by 2050. So for, you know, a company that is mostly gas, although we're also an electric company, as most of the folks in the Kootenays know, is a pretty steep target that we're heading towards. Now, in terms of why do we do energy conservation, to hit those targets is something that we absolutely need to do. We are also mandated by the province in terms of infrastructure. When our customers reduce their load, especially at peak times, it helps us extend the life of the current infrastructure that we have in place. So overall, is a wise investment for us to have in energy efficiency conservation, and you know, that's kind of why I'm here today. This is probably well known by everybody, but heating spaces is the biggest load of energy in your home by a long stretch. So this is kind of the area that we would like to focus on. As we mentioned before, building envelope first is what we advise and we suggest. So what we're doing is we have a series of rebates. Currently, my last count was over 80 rebates, and it's interesting that the comment before, there was some quirky rebates. Yeah, I guess there are some quirky rebates. We have all kinds of rebates. So I'll mention some of those. I think to the earlier question about can you stack up the rebates. So for heat pumps, you can't, but if you do something like a heat pump and then you change your lighting, you could, or building envelope as well. And we actually have bonus rebates if you do more than one measure at the same time. So keep that in mind. And a big part of what we do is energy efficiency education. And so this is why we're promoting this and sponsoring these type of events. And, you know, we try to work with industry to build that capacity. We didn't talk a lot about that, but we know it's an issue in some parts of the province, particularly in the Kootenays. So we're trying to help bridge that gap. In terms of heat pump rebates, which was the topic today, so depending on the efficiency, so if you have a heat pump on the lower efficiency rate, the rebates start at $1,200 and they go up to $2,000. We also have a heat pump loan program up to $6,500. And we also have rebates for a service or connected thermostats as well, depending on the product. And one of the things that I wanted to mention today is that we have hybrid system rebate coming up in a couple of days. So what that means is that when you have a heat pump paired with a furnace, where the heat pump is taking most of the load, but when it gets really cold, then the furnace kicks in to shave that load peak. We will be incentivizing those systems, and it's imminent. I couldn't get the information for this presentation as it hasn't been 100% approved, but in a couple of days you'll see it throughout our social media and in our website. These are some of the core key rebates that we mentioned before. So you can get these rebates in basically in store. So I have a list here of some of the Canadian Tire, the Home Hardware and Building Centers, and maybe some online options, as well as if you are in Kelowna, if anybody's reaching from Kelowna, the Home Depot here in Kelowna and the Costco also have these rebates that you can access right from the retailer. Or type of rebates that you can add depending on where you are. These are geared towards the folks that are in the Kootenays, so that they're both gas and electric customers of ours, are for washers and dryers, refrigerators, windows and doors, which are part of the building envelope that we mentioned before. And we talked a lot about insulation rebates earlier today, and we think that for a manufactured home, it's probably a best starting point for you to look at that. So here are some of the areas where we incentivize rebates, the type of insulation that qualify, and it's basically by square foot that you can get the rebates for those. Now, the new home program, which is brand new, and this is kind of related to the whole push that we're doing for hybrid heating systems, we think is the best approach for the overall energy transition, if you will, where you have a furnace integrated with a heat pump. And in this case, if you have electric heat water as well, is one of the options. Or when you have combi space and water heating system integrated with a heat pump, again, this is kind of like a boiler system that would provide the hot water for your home and maybe kick in when the heat pump is not at a certain set point when it's getting too cold. And lastly, an electric furnace or baseboard or heat pump combined with electric water heating. This is particularly today, I can see a system in a manufactured home where you have a heat pump and an electric water heater. We can incentivize those as well for new homes. So the switchover temperature that was mentioned before basically means that this is the temperature when one system will switch to the other. And in climate zone 4, it would be anything lower than 5 degrees. And for climate zones 5, 6, and 7, which, in the Kootenays, I believe we're zone 5. Is that correct, Jenna? Do you remember?
Sorry, I was reading a question in the chat. I missed that one.
Oh, no, yeah. What climate zone are we in the Kootenays? Is it 5? You don't know? Okay, I think it's 5. Yes.
Parts are 6.
Parts are 6. Okay. Thanks, Rob. Ryan. Okay, so those are the switchover temperatures. And here is a table with the incentive levies that we have for new homes. So for step 4, we're incentivizing anything above and beyond what the province's base mandate is, which is step 3 right now. So for step 4 homes, we had a limit of $10,000 rebates before, and we increased that to $15,000. And for step 5, which was also $10,000, we increased that to $20,000. So we've increased our rebates for that because we feel that is more aligned with the ability for us to incentivize those higher steps for new homes. You can also access the other rebates like electric dryers, washers, fridges, and connected thermostats as well. And for those energy advisors in the call, we provide $1,000 for the energy advisor support. And there is also an optional and milk construction blower test, which is always helpful as you're building your new home to incentivize that by a rebate of $500. Program eligibility, this is for detached homes, duplexes, townhomes, and also manufactured homes. The applications must be submitted at the beginning of this year, so anytime now. The homes must be in a permanent foundation, and this is also for the heat pump rebates that we mentioned before. There was a question about if you needed to own the land. You don't need to own the land, but your house needs to be fixed to the permanent foundation. So that is the requirement there. And in terms of renters could also access the rebates. So that's not a problem. When it's a heat pump, is not always the case that a renter would make such a big investment in a home that is not their own. But all you need is we have a standard form that your landlord can fill in, and you would be able to access those rebates. And the application must be submitted within 6 months of the project completion. So I think that's all I had today. Thank you for your time, and I wonder if there are any questions.
Yeah, thanks so much, Juan. I'm wondering if you can speak to any requirements around contractors who are doing the work.
Yes, so they need to be HPC and certified. So that is really the biggest part. Ryan mentioned before that it is important to have the heating load calculations. So that is also a requirement of ours, to make sure that you're correctly sizing the equipment. So maybe a couple of things to keep in mind there. We have a list of eligible contractors in our website. If you look them up, it's called the Trade Island Network. So depending on where you are in the province, we have certain requirements that they need to have the insurance, $2 million insurance, that they're in a good standing as a business. So, it's a reputable businesses for the most part. I don't think we have a requirement that they need to be HPC certified, so you need to check that further before you engage with a contractor for installing a heat pump.
Great, thanks, Juan. Any other questions from folks on the call? Feel free to unmute yourself or pop it in the chat. We do have a couple minutes here. I guess that means you were very thorough.
Or maybe not. Maybe I went too fast.
No, I don't think so. All right, I'm not seeing anything pop up there. Okay, well, thanks so much, Juan. Thanks for letting us know. I know there are all sorts of different rebate programs out there, so it's nice to have a reminder of what's available. And thanks to you again, Ryan and Rob, for imparting your knowledge on us. And thanks to everyone on the call for joining us. I really appreciate you taking the time out of your morning, and yeah, we hope you enjoy the rest of your day.
Thanks, Jenna. Thanks, everybody.
Thank you.